Good morning, everyone. Thank you for being here today. We are about to dive into the foundational concepts of computer science theory. This field is at the heart of every digital system we use, from our smartphones to the website we visit. Understanding the basics of data presentation, data storage, compression, communication technologies, and internet security will give us a strong foundation for tackling more complex topics in the future. So let's start with one of the fundamental building blocks of computing, data representation. In this chapter, we're going to learn about the number system conversion, such as we have decimal to binary, where we divide the decimal number by 2 and record the remainders. For example, we will convert 150, the decimal number, to binary. And as we can see, we will divide this number by 2 each time and record the remainder. So first time, we get answer 75, and we have the remainder 0. So we will repeat this process until our final result is 0. And then we collect all the remainders and reverse them to get the final binary result. Other than this, we also have binary to decimal, where we multiply each binary digit by 2 raised to the power of its position, starting from 0 to the right, and sum the results. For example, here we given the binary number 1001010. So according to their position, and we will add those numbers together, so we got 148, which is the decimal number. Other than this, we also have decimal to hexadecimal. And to convert decimal to hexadecimal, divide the decimal number by 16 and record the remainders. For example, we use 55 as a decimal number to divide 16, so the final result we get is 3 and the remainder is 7, so the hexadecimal number is 37. We also have hexadecimal to decimal, where we multiply each hexadecimal digit by 16 raised to the power of its position, start of 0 on the right, and sum the results. For example, we have 1AB, which is a hexadecimal number, and we need to convert it to decimal number. So we multiply these numbers with their position, and the final answer will be 256, add 160, and add 11, and we get 427 as the decimal number of 1AB. And then we also have hexadecimal to binary, where we group the binary digits into groups of 4 from the right and convert each group to a hexadecimal digit. For example, we have the number of binary we have 1011, 1100, and 1001. So we separate it into 1011, which is B, 1100, which is C, and 1001, which is 9. So the hexadecimal is BC9. To convert hexadecimal to binary, we convert each hexadecimal digit to a 4-bit binary number. For example, for BC9, B is 1011, C is 1100, and 9 is 1001. So the binary number of BC9 will be 1011, 1100, 1001. And then here comes the second part we call data storage, where we have character storage. We use ASCII, and it uses 8 bits to represent characters and is suitable for standard English with 256 possible characters. For example, the letter A is 01000001. Unicode uses 16 bits and has 45,536 possible characters. Other than this, we also have image storage, where we know images are made up of pixels in a black and white image. 1 represents a black pixel and 0 represents a white pixel. In a color image, each pixel's color is represented by the RGB color system, with each color channel, red, green, blue, using a byte. The resolution of the image determines the number of pixels and affects the file size. We also have sound storage, where we record it by a microphone and sampled at set time intervals, then converted to binary. The sampling rate is measured in hertz. For example, a telephone communication samples at 8,000 Hz, and a CD samples at 44,100 Hz. The closer the sampling intervals, the higher the sound quality. And here we come to the data compression, where this is the process of reducing the size of a file or dataset to save storage space or transmission time. By compressing data, we make it more efficient to store and transfer, which is especially important in areas like multimedia, web browsing, and file storage. And here we have 2 different kinds of compressions, which they are lossy compression and lossless compression. For the lossy compression, it removes redundant or unnecessary data permanently to reduce the file size, commonly used for multimedia files like audio, video, and images. For example, in a music file, it may remove background noise not easily audible to the human ear. And for the lossless compression, it does not lose data during compression. It can reconstruct original data file exactly. For example, in a text file, it may store repeating words and their positions. Consider the message, when it is snowing heavily, look outside. Look outside, it is snowing heavily, which can be compressed by storing the words and their positions. And then we have the file format, We know different data types are stored in different file formats. The file format encodes and organizes data in specific ways, and the file extension identifies the format. Common file formats include doc for Microsoft, Word documents, MP3 for audio files, and JPG for images. Multimedia standard file formats include MIDI, which is used for instrument connection and communication, not a music recording but a series of instructions. JPEG, which is a standard for lossy image compression, MP3 for lossy audio compression, and MP4 for lossy video compression, and can also be used for other data. Now, we are going to talk about the next chapter, the communication and internet technologies. And we are talking about the data transmission, where we have different transmission things, such as transmission methods. Serial transmission uses a single wire to transfer data bits one at a time, suitable for long distances with low cost but slow speed. Parallel transmission uses multiple wires to transfer data bits simultaneously, faster but more expensive, and limited to short distances, about 5 meters, and more prone to interference. For example, a computer's internal components and simple computers like integrated circuits may use parallel transmission. And we also have transmission directions, where simplex transmission sends data in only one direction, like a television broadcast. Duplex transmission allows data to be sent in both directions simultaneously, like a telephone conversation. Half-duplex transmission allows data to be sent in both directions, but only one direction at a time, like a walkie-talkie. And at last, we have error detection and correction, where checksum counts the number of bits transmitted and the receiver checks if the count matches. Parity check adds a parity bit to a byte, usually 8 bits with the last bit as the parity bit, to ensure the data is sent accurately. It can be odd or even parity. For example, for 1001100 with even parity, the parity bit is 1, because 1 plus 0 plus 0 plus 1 plus 1 plus 0 plus 0 is 3, an odd number, so we add 1 to make it even. Check digit is used for identification numbers, like barcodes, to detect human error. Automatic repeat request, ARQ, makes the receiving device request the sender to resend a packet if an error is detected. And then we have the security aspects, where we have internet security risks. We know there's malware, where it includes viruses and spyware. Viruses are programs that can replicate and harm a computer and its files, often spread through sharing files and emails. Spyware collects user information without permission, usually for marketing or illegal purposes, and can also reduce available bandwidth. Hackers try to gain unauthorized access to a computer or network, and they can be classified as white hat hackers, who expose security issues for good reasons, and black hat hackers, who gain access illegally. And there are also some protection measures. Antivirus software scans the computer's hard disk to detect and remove viruses, malware, and spyware, and needs to be updated regularly. Firewalls, which can be hardware-based or software-based, monitor and control the transmissions in and out of a computer or network based on rules, protecting the computer from unauthorized access and malicious software. And we also have Internet Principles Operation, where we separate it into Internet Service Provider, ISP, Internet Addresses, Internet Browser, Web Server, and Internet Protocols. So first, we will talk about Internet Service Provider. It provides access to the Internet, usually for a fee. Customers need to follow the ISP's terms of service, which may include data download limits and legal regulations. ISPs may also allow users to personalize their Internet access, such as setting filters. And then, we will introduce the Internet addresses. The IP addresses identify devices on a network, with IPv4 being 32-bit and divided into 4 groups, while IPv6 is 128-bit URLs, consisting of an access protocol and domain name, are user-friendly web addresses translated into IP addresses by domain name servers. Additionally, MAC addresses are 48-bit unique identifiers for devices, and cookies are small data files used to track user activity and preferences, though they can also store sensitive information and be managed by users. And then we are talking about Internet Browser. Internet browsers are used to access web pages. It translates the website URL entered by the user into the server's IP address, downloads and displays the page content, and allows users to navigate to other pages via hyperlinks. And then we have the web server. Web server will store website pages and content and handles requests from clients. Downloading is when the client retrieves information from the server, and uploading is when the client sends information to the server. Powerful servers are used to host popular websites, but they may crash if there are too many requests, like when tickets for events are released online. They can also be attacked by distributed denial of service (DDoS) attacks. And then we have the Internet protocols. Internet protocols contains HTTP and HTTPS, where HTTP is a protocol for internet data transmission, with HTTPS providing a secure version for sensitive applications like banking. HTML, the language for web pages, uses tags to structure content and define formatting, while CSS separates content from presentation for easier updates. Together, they create structured, interactive, and visually appealing web pages. And that's all for today's course. Thanks for listening.